Hi. So this is joint work with Rahul and Tanaya. Unfortunately, Rahul was supposed to come, but he couldn't. So I'm presenting it for him. So the first two authors are more of HCI people, and I was a computer vision guy, and they were basically interested in computationally understanding person's behavior, right? So the subproblem that we took up was how to analyze a public speaker's behavior, and you would think that content of the talk, the tone of the voice, the physical appearance, etc., non-verbal behavior, all of these are important. In this particular work, we are interested in quantifying how visual behavior or visual appearance of a speaker affects the likability of the talk. So basically what we would want to look here is if I give you these visual cues, facial attributes, for example, if the person is wearing eyeglasses, is he or she smiling, etc., and then pose, the kind of gestures the person is making while making that speech, and then eventually attributes, what is the approximate age of the person, what kind of clothes the person is wearing. These kind of visual features, how much can they affect likability of a talk, of a visual performance? So there is a lot of work in psychology and sociology. They try to figure out what people think when they look at a talk, which they find very interesting. There are much less works in computationally quantifying this. So ours is one in that direction. It's a simple application paper with a slight novelty. So the first thing what we had to do to study this problem was to actually have a data set. There was no data set available to study this kind of a problem. So we looked at TED Talk videos, and we downloaded a bunch of them, and we made sure that it was just a single speaker video, and so we rejected when there were multiple speakers, etc. So, and we captured all the metadata we could alongside the video, so views, likes, dislikes, comments, etc., and single person videos like these examples, and we constructed a data set of about 1,800 videos, with each video being about, on an average, 13 to 14 minutes long. So with this, now we had to kind of quantify what is the ground truth, what is the popularity of a lecture. So one way would be to actually have manual ratings, but in this work we kind of use a cheap proxy, and we use this metric, which we think is a proxy for likability. So if a person watches that video, does he or she likes it as well? So the ratio of like divided by views is our proxy for the popularity of the video. So this becomes a kind of the ground truth that we want to regress on. Okay. Now the architecture is quite simple. We have 3 streams of deep networks, and eventually they're fused. I'll show you in a while. So the first stream is the attributes. These are pre-trained on a standard data set. Second stream is on pose. This is also pre-trained on some standard data set. And the third stream is of human attributes, again, pre-trained on some standard data set. Eventually, we would also say that, okay, at one point, the human would probably be focusing on one of these information channels. Okay? So there should be an attention mechanism that at any point of time, the person is paying attention to one out of n channels available. So we propose this architecture where you basically, towards the bottom, if you see, you have the 3 streams coming, and then there is a attention prediction mechanism, which basically predicts floating values, real values, a probability distribution, if you may, on the attention of the channels. And then modulated by these attention weights, we stack the channels to do the final classification. So we see, the first thing we see is that face is the most important channel. We can talk about these numbers more over the posters. And then we get these kind of visualizations. So whenever a high resolution face is available, the method kind of goes for the face, and then successively it likes pose and then eventually attributes.